Okay, year 10. So if you get yourself your notes open at page 43, please. We're going to fill in some notes today and it will involve a little bit of a recap on what we have been doing plus another little extra bit. Okay, so page 43, get yourself open and ready to go and then hit play again. So recently we have been looking at cumulative frequency. And then if you remember, we were plotting our cumulative frequency curves. We're going to look today eventually at what information we can actually find out from those cumulative frequency curves. Okay, so we never actually filled this example in on page 43 and it is a good wee recap now. So the number of games that children had for their games console is given in this table here. How many children have got more than 20 games and how many children have got less than 16 games. So we could answer this without doing our cumulative frequency and I'll show you how, but then I'll show you it with the cumulative frequency as well. So for A, what was it? How many children have got more than 20 games? So that's going to be these two numbers here added together because we've got 21 which have between 21 to 25 and we've got 10 from 26 to 30. All these ones, and these ones and these ones and these ones have got up to 20. So 21 plus 10 gives us 31 children. Okay, and then B, less than 16 games. Well, that's going to be all of these ones added up together because these ones are all 16 and above. So this one plus this one plus this one all fall into the category of less than 16 games. So, again, that's 31 children. Now, if we had our cumulative frequency column, that maybe would have made this a little bit quicker once that column was in. Now, you might not agree with me on that, but because these questions tend to come with drawing the curve, you're going to need that column anyway. So let's get that done. So remember, cumulative frequency, it's just like a wee running total where you add up as you go. So if we have, I should have added in my extra wee column here. Okay, sorry about that. So I've added in an extra column here for games and then our cumulative frequency column. So this here is going to be like showing what this number represents. So if we're looking here, this is for games which are less than or equal to 5. And there's 5 of them. If we're looking at the number of games which is less than or equal to the upper limit of this group, which was 10, then we've got this 5 plus we have this 9, so that's 14. Here we're going to have games which are less than or equal to 15, and then that's going to be these 3 added together. But instead of adding up all our individual ones every time, we can just take our last cumulative frequency, the 14, and add on the 17 to it. So what's that going to be? 31. Next one, less than or equal to 20. We take this one here because that's everything up to 15, and then we have to add on our 28. So 59. Here we're looking at games less than or equal to 25, and we're going to have to add on this 21 to this, so that is 80. And then less than or equal to 30 games, add on this 10, and we've got 90. Okay, so I'll quickly go over how I would have answered A and B there. So for A, how many children have more than 20 games? Well, it's going to be the total 90, take away this 59, which gives me the 31. Both methods I think are equally as valid for that. How many children have less than 16? For that, this method's definitely quicker because all we have to do is go to 15 or less is 31, and that's just reading that off there. Okay, next page. Now, there's a bunch of notes here about different values that we can get from our cumulative frequency curves, okay? I'd rather just talk to you about it rather than just read through this. So, whenever we have a set of data like this, we've got loads and loads and loads of values. Remember we spent a bit of time looking at all the different averages that you could find. They're useful. Another thing that is very useful to find is the range in the data, because that can just tell you information about it. But what we often find with data is that most of it is grouped like in the middle of the group, and then you've got the odd wee one out here and the odd wee one out here. So we have this different like version of a range. Now I maybe shouldn't have said that because it's not exactly the same as the range, and it's really just measuring how far apart the first quarter and the third quarter in the values are. Now this does sound very, very strange, and the first time you see this now is it can be a little bit tricky to get your head around, but the more you practice it, you'll get used to it. And I'll show you what I mean whenever we're doing our graphs, okay? But really the interquartile range is what we're talking about there. It's like gives you an idea about the spread of the data, but it's ignoring those extreme values, so the extreme really high or the extreme really low. Okay, so it's ignoring those because there always will be extreme values. In a class test, you're going to have probably the bulk of the class in like maybe 70s, 80s. You'll have the odd person up in the high 90s, and then you'll have the odd person down really low. So the interquartile range will give you that spread in the test results, ignoring the really, really high and ignoring the really, really low. And it just gives an idea about, in that case, how the majority of the class are getting on. Okay, I said I wasn't going to, but I'm going to read through these. So cumulative frequency curves help us to find the median. So do you remember finding the median whenever you list everything in order and it's just the middle? And a measure of spread called the interquartile range. So the interquartile range is found by subtracting the lower quartile value from the upper quartile value. This all sounds really fancy. I promise it's easier than it sounds, right? So the lower quartile, which we call Q1, determines the lowest quarter of the distribution. The median, which can be called Q2, I mostly stick to median for it, splits the distribution into equal halves. The upper quartile, Q3, determines the highest quarter of the distribution. And then the interquartile range is the difference between these two. So the difference between the upper and the lower. So it's Q3, take away Q1. Now there are notes here on finding the quartiles. That is going to look like nonsense to you until you see it on a graph. So that's what we're going to do now. Okay, so on page 45 we've got this example here. It is about the heights of 200 trees in a forest. So we've got different height groups, and then we have the frequency, so the number of trees which are in between these two heights. First thing we have to do is do our cumulative frequency table. Now we're going to need an extra column on this. I don't know why there's only 3. So I will sort mine out here and then I'll ask you to pause to get yours done. Okay, so if you can see that, all I've done so far is take this table and turn it vertically, and then I've added on these extra columns. So this height is just this little row here put into here. And let me just remind you what all these symbols mean. So let's look at this one. This one here means a height which is greater than 2.5 and less than or equal to 5 meters. And there was 30 of those. Here, this group here is for trees which had a height greater than 10 meters and less than or equal to 12.5 meters. There was 36 of them. This one, heights greater than 12.5, less than or equal to 15, and that's 8. Now pay close attention to these signs here. They are important because if we didn't get those right, like say for example a tree which was 12.5, well that has to go into this group, because see this wee group here, it's for heights which are greater than 12.5, whereas this one is for heights less than or equal to 12.5. So you always need to make sure there's a clear distinction for your values to go into one group or the other. It can never be possible for them to go into 2 groups. So pause, get this written in, and then unpause and we'll do the rest. Done? Okay, so I've added on these 2 extra columns here because remember, whenever we're plotting our cumulative frequency curve, which is our next bit here, we always plot the cumulative frequency at the upper limit of the group. So if I'm looking here, I've got 10 heights from 0 up to 2.5, so less than or equal to 2.5 meters. I don't have to put my unit on my value because it's up there, and I've got 10 of them. I'm going to get my calculator because you know I'll make a silly mistake adding these up. Okay, so next one, if I'm looking at heights which are less than or equal to 5 meters, Well, then I have this 10 and this 30. Don't need my calculator for that. That's 40 trees. If I'm looking for trees which are less than or equal to 7.5 meters, well then I've got these 40 trees plus this 56, so that's 96. Then less than or equal to 10. I really shouldn't be using a calculator for this, but look how many silly mistakes I've made in these videos. 156. Less than or equal to 12.5 meters, we have to add on these 36, gives us 192. And then less than or equal to 15 meters, we have to add on these 8, which takes us to 200. And it did tell us there was 200 trees in the forest, so we know we're probably right there. Okay, so make sure you've got that written in. Now, part B is asking us to draw our cumulative frequency curve. This is set up quite annoying. There's going to be quite a lot of flicking backwards and forwards, but we'll cope. So, cumulative frequency curve always has cumulative frequency up the side, and then like whatever it is you're talking about along the bottom. So in this case, it's going to be height along the bottom. So let's figure out our scales here. Let's go for height first of all. We have to go from 0 all the way up to 15. So turn over to 46, and I'm going to do this right at the bottom here. What was it I had to go to? 15? Yeah. So let me see. Bet you I can do 1 square for every meter. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, so let's do that. So I've used my ruler to draw my axes, and then on the line I've just labelled every one. So every meter, labelled my axis, height, h, measured in meters. Now, the y-axis has to be cumulative frequency, so I have to go the whole way up to 200 here, so let's figure out that scale. Okay, I've had a wee look at the number of squares. I reckon if every square we use is 10, that will work out as quite a nice scale. So I'm going to do that. So, starting off at 0, every one we square 10, nice wee straight line using your ruler up there, and labelled cumulative frequency. Okay, I'm struggling to get this to fit the whole thing in. Right, let's get plotting our points. So if we look back over here, remember we always plot, so this is our x-axis and this is our y-axis. We always plot at the upper limit of the group. So at 2.5 we're saying there's 10 trees which are less than or equal to 2.5 meters. So 2.5 is going to be here, and there was 10 trees, so I'll plot my point there. Okay. Next one, there's 40 trees which have a height of 5 meters or less. So I go to 5 and I plot my point at 40. Next, there's 96 trees with a height of 7.5 meters or less. So I go to 7.5. So I'm going to use my ruler just because, you know, I'm prone to silly mistakes. And 96 is going to be probably about there. So pause me, do the rest of those yourself, and then check back in and see does yours match mine. Okay, I can just about get that all in, but here's my points. The next thing I'm going to do now is just draw my curve. Okay, there you go. So nice and slow and steady, and remember what we talked about last time we were doing this, doing your wee practice run, turning your page if you need to make it easier for your wrist. Whatever works for you. Okay, so hopefully you've got your curve drawn, looks something like this. Let's go back to our question. So we've done this. Use your cumulative frequency curve to estimate the median and then the interquartile range. So let's look at that. So the median, remember, is halfway. So if our cumulative frequency goes up to 200, then I need to go to 100, go across and read down. So, get my ruler, I'm going to 100, and I'm ruling across, and then I'm going to read off what value that is. Now, because this isn't proper graph paper, we're going to have to do a little bit of estimating. I reckon, so this is about 7.5, it might be 7.6. So 6 of one, half a dozen of the other. Let's label this as the median line, just so we know whenever we're going back to it. So our median, I'm just gonna go 7.5, okay? And I'll list it over here. So C part 1 median value is 7.5 meters. Does that make sense? Is it roughly in the middle? Yeah. Okay. Part 2 then, the interquartile range. So do you remember the interquartile range gives you information about the spread and the results, but forgetting about those extreme values. So we go a quarter of the way up and we go 3/4 of the way up. So a quarter of the way up is going to be at 50 out of 200, 50 is a quarter. We go across until we hit our curve, and then we go down. So if you remember, the first quarter we call Q1, and that's coming out at 5.5. For me, yours might be slightly different. So Q1 is 5.5 meters. Then we find Q3, so we go 3/4 of the way through our data. So 150. Go across until we hit our curve, and then go down. So this one, if you remember, is Q3. So I'm going to call that, for mine, 9.8. You put whatever yours is. So Q3 is 9.8 meters. So this interquartile range tells us about the general spread for getting those extreme values. So interquartile range is Q3 take away Q1. So for me, that's 9.8 take away 5.5. Remember, if your values are coming out different, you use yours. So 9.8 take away 5.5 gives me 4.3. Okay. Part D, so we've got that and we've got that. Part D, what percentage, be very careful with this, of the trees are over 7 meters high? So let's look. This time we're going to be going the other way around in our graph. So we go to 7 meters, right? We go up until we hit our graph, and then we go across. So that for me is coming out at about, let's say, 84. All right, I'm going to write that wee one on there. So this 84 tells me that there's 84 trees with a height of 7 or less. So let's make a wee note of that. So for part D, 84 trees are 7 meters or less. Let's look back at what the question's actually asking. What percentage of the trees are over 7 meters high? So if I take this number away from 200, what do I get? 116. So that tells me there's 116 trees are over 7 meters, which is what that's asking about. But it didn't ask for the number, it asked for the percentage. So we have to find what percentage 116 is of 200. So the percentage is 116 divided by 200 multiplied by 100. And I've got 58%. Okay. So that's all I'm asking you today, because that is a completely brand new thing to you. I do need you to spend your time going over, making sure you know what all these words mean. So upper quartile, lower quartile, first quartile, third quartile, median, interquartile range. Get to grips with those, because next lesson you're going to be doing an exercise practicing this stuff. So what I need you to upload for me today is just pictures of these filled in notes, but I'll put that into the assignment. Okay, let me know if you need any help.